How to compare and order decimals. First, we have to take into consideration decimal place value. Decimals are commonly used to represent money. So $1 is 1 whole, a dime is 10 cents, or 1/10, and a penny is 1 cent, or 1/100th. It takes 10 pennies to make a dime. It takes 10 dimes to make a dollar. So it takes 10 hundredths to make 1/10, and 10 tenths to make 1 whole. We can write fractions in decimal form. It takes 10 1/10ths to equal 1, and 1 1/10 is 1/10 of 1. The decimal separates whole numbers from decimal fractions. Writing fractions in decimal form, 37 out of 100 equal parts. So we write that as a decimal, a 0, a decimal point, a 3, and a 7. In expanded form, we could write 3 times 1/10, or 3/10, plus 7 times 1/100th, or 7/100ths. The fraction form is 37 over 100, and we read that 37/100ths. Notice that the fraction and the decimal should be read the same. A decimal number can be understood by looking closely at the place value of each digit and seeing that it takes 10 of the value to the right to make 1 of the value immediately to the left. Representing decimal numbers as lengths, suppose we want to compare 151 thousandths and 3/10ths. Some students are under the impression that the longer the number, the larger the number. So this is a way to help them understand that is not correct with decimals. So we're going to use the same color coordination that we did before. Tenths will be orange, hundredths will be yellow, thousandths will be blue. So if I use a rectangle, an orange rectangle, to show 1/10 in the 151 thousandths, and 5 yellow rectangles to represent the 500ths, and 1 blue to represent the thousandths, and then for 3/10ths, I just use 3 orange rectangles, you can see that 3/10ths must be larger than 151 thousandths since it's longer. So this is using lengths. We can do it again with 123 thousandths and 13/100ths. In the tenths place, you could see we would use 1 orange rectangle for both of them. In 123 thousandths, you would use 2 yellow rectangles for the hundredths and 3 blue rectangles for the thousandths, where in the 13/100ths, you would just use 3 yellow rectangles. They're close in length, but I hope you can tell that the 3/100ths is longer than those 3 thousandths. So therefore, 13/100ths is larger. Here's an example you can put on a number line. So you're going to use quarters as benchmarks to approximate the decimals on the number line. Label the points underneath the number line. So we're trying to put on a number line 1 and 6/10ths, 2 and 9/10ths, -1 and 4/10ths, and -2 and 8/10ths. So first split up in between each whole number it into 4 pieces, so quarters. So there's my answer on the number line. You could see that -2 and 8/10ths is almost to -3. -1 and 4/10ths is almost to -1 1/2. 1 and 6/10ths is a little over +1 1/2. And 2 and 9/10ths is almost to +3. When we're comparing, because the number system is uniform, students can use the same place value understanding for comparing larger numbers or smaller numbers. So which is larger, 9/100ths or 2/10ths? I'll start with the largest place value. Here it's the tenths place. The number has 0 ones, 0 tenths, and 9/100ths. The other number has 0 ones and 2 tenths. If you shade them, you can tell that 0/10 is smaller than 2/10, so 9/100 is smaller than 2/10. Be sure you look at your symbols to make sure you have them written correctly. How about 18/100 or 173 thousandths? Again, if you start from the left, they both have ones in the tenths place, but when you move to the right, 18/100 has an 8 in the tenths place and 173 thousandths only has a 7 in the tenths place. Therefore, 18/100 is greater than 173 thousandths. When you're ordering decimals, you need to describe the strategy you're going to use. You could use a place value chart and then order them. Sometimes it's easier to add zeros as placeholders or put them vertically in a place value chart. Some students misunderstand and think the longer the decimal, the bigger the decimal, and that's not always the case. So it's really nice to make all the decimals the same length, so then you can compare them. How about if they're negative? What happens then? Explain in your own words how you can determine whether one negative number is greater than another negative number.